hi everybody, welcome to the second episode of Vega IT's TechPod. Today we have a special guest, a software architect with more than 35 years of experience in the field. He has a hands-on experience with architecture, design, implementation of microservice architecture, service-oriented architecture, and other distributed systems in a variety of technologies. He is the founder of Developer to Architect website and author of multiple books like Software Architecture, The Hard Parts, and Fundamentals of Software Architecture. His name is Mark Richards, and today we'll talk about microservices versus monolithic architecture, cloud versus on-premise, soft skills, people skills, and domain knowledge. So, hi Mark. I would like to welcome you to Vega IT's TechPod, technical podcast. It's an honor to have you here and listen to you share knowledge about software architecture and soft skills and all the subjects that we are going to talk about today.
Mm-hmm. Yeah, well, thank you.
Yeah, okay, so maybe we can start like before all the technical stuff and all the complicated things, just to get you warm up. Maybe we can talk about your books. You have written a lot of books and you published a lot of them this year, and you have one that's planned to be published on December this year. Yep. So maybe you can tell us a bit more about that.
Yeah, that'd be great. First of all, thank you again so much for having me on the podcast. And yeah, so recent books that I've written with my friend Neil Ford were the Fundamentals of Software Architecture, which we published back in beginning of 2020. And then following that, Software Architecture, The Hard Parts. And both of these are turned out to be very popular books, but really kind of tried to capture the essence of this thing we call software architecture, which is actually kind of hard to define. A lot of times people want to become an architect, but don't know what that path is. Or a lot of cases, you become a software architect and you scratch your head and you say, I'm not sure what I'm supposed to be doing. And so those are really addressed in our first book, which is the Fundamentals book. Mm-hmm. And that kind of distinguishes itself from other architecture books out there in that it really covers all three aspects of software architecture. It covers some of the foundational aspects of architecture, the technical aspects of architecture, which are all the technical styles and patterns and stuff, and then kind of the techniques and soft skills, which I hope we'll have a chance to touch on in the podcast. But then what happened was, after about 450 pages, we ended up with all this leftover stuff that we wanted to talk about. Things like distributed transactions and all the real hard parts about distributed architectures. And it wouldn't fit all within one book. And so that's when we said, these are the hard things. Maybe we should have a separate book. And that's where the title, The Hard Parts, came from. And that really is more of a technical focus on distributed architectures. But you had mentioned our upcoming book. So we embarked on a project about 2 years ago, about 1.5 years ago, on a O'Reilly Head First book. And that one's titled Head First Software Architecture. And it's an interesting journey because those of you not familiar with the Head First series at O'Reilly, these are very graphical books. It's almost writing like a graphical novel. There's not a whole lot of words. It's mostly images and pictures and conversations between people. And it was very different writing that book than our other prior two. When you open up any technical book, I've got a lot of them here on my shelf. It's just, it's paragraph after paragraph of words and maybe a diagram here or there. This is an entirely different way of teaching. And I'm really, so we're about 3/4 of the way through the book. It's probably going to be released around December of this year. But I'm appreciating the the method of teaching, it's a lot different than picking up a technical book and kind of reading a lot of words. And so we've actually been really enjoying this experience, although it is hard.
Yeah, I believe so. So, Mark, you wrote a lot of books. So I believe that anybody who wants to become a software architect or already is, should read most of them, if not all. But I have a question for you.
Sure.
What is your favorite book?
I'd have to say not. I can't include mine. That's one of the first rules, Milan. So we'll say that I can't include my book.
Okay.
But a couple that I really appreciate. Gregor Hope a couple years ago wrote a book, The Architect's Elevator, and that is a great book about just communication and collaboration. A lot of those soft skills that an architect has to have to be able to not only collaborate with business stakeholders at the top floors where the elevator is, but also down in the middle floors and even bottom floors where developers and IT staff and operations. And he does this metaphor of an elevator, which is really clever. But that's a great book. So that's one. I'm not sure I have a favorite, but I've got a lot of really a lot of favorites, I guess. But that one stands out as one that I usually highly recommend to people. Yep.
Yeah, that's very nice. Thanks, Mark, for that.
Another one, though, I will mention, although it's not cheating, because I do have 4 chapters in the book, but another really, really good book if you're thinking about software architecture or really want to kind of understand it, is another O'Reilly book, 97 Things Every Software Architect Should Know. And this is a collection of 50 really top architects in our industry. And each page or each chapter, well, there are chapters, but it's just a 2-page spread, has a picture of the person, of the architect, and then just a 1-page tip about software architecture. And it's a fun book to read, but that has a lot of really good tips about architecture, both the technical aspects and also the soft skills aspects of architecture. So that would be another one that I would highly, highly recommend.
Yeah, I would say it's really important not to have only technical skills. Like the soft skills are also really important for software architect, but people often forget that. They only think like, okay, I know how to do distributed transactions and the rest of the things, so I'm ready to be an architect. But I would say you're not still. So you have a lot of work on yourself to because you have to talk to people, discuss all the things, etc.
Right, exactly. Yeah, yep.
Okay, so Mark, I believe that you're ready to go into some deeper and complicated subjects. Yeah. Okay, so the hype train the past couple of years, the microservices. So I'm not even sure where to start, but what would you say about microservices architecture? When to use it, when not to use it? Any tips from all the books that you wrote and read?
Well, you are right. It definitely caught the hype curve, didn't it? Wow. So I've been in this industry now for believe it or not, 37 years, and 27 of those I've been a software architect. But about the past 10 years or a little more, I pretty much have devoted most of my career to microservices. I've been working on both greenfield as well as migrations of microservices. And it has been, Milan, such an interesting journey. You're right. Where to start? I do think that what I've observed in my 10 plus years of my journey in microservices, helping companies and stuff, that we're getting to a better understanding of this architecture style. I do agree. A lot of people jumped on the bandwagon, so to speak, and embraced microservices without really fully understanding how complex this architecture style really is. One of the things I like to say about microservices, that it's both revolutionary, but also evolutionary. And I came up with that because there was one particular conference about maybe 6 years ago, maybe 7 years ago, where somebody had asked me, do you think that microservices is revolutionary or evolutionary? And Milan, the question caught me by surprise because I really didn't expect the question. And I was standing there on stage and it was like all quiet. And I'm like, wow, I've never thought about that. And anytime you can kind of stump a speaker like that, you know it's a really good question. So I kind of sat there for 30 seconds or stood there for 30 seconds. And I'm like, which is it? And that's when I said, my brain is going back and forth. And I answered both. And then I really started thinking about that question, and I really do think it's both evolutionary and revolutionary. Let me give you an example. The evolutionary aspect means eventually we would have arrived at this architecture style. The advent when Jez Humble and Dave Farley wrote the continuous delivery book, that was a major inflection point in our industry. I mean, that was one of the challenges we had about how do you just deploy software effectively. And it was interesting because the techniques that they described in that book were fantastic. But most of the time we were stuck with large monolithic systems or systems that had fairly large services. And it wasn't very effective. And so we started saying, what would make this more effective? Well, let's start breaking up those applications into smaller pieces. And it started to become more effective. And then we said, whoa, let's break them up even smaller. And it became even more effective. And so that was one of the evolutionary tracks of eventuality within this architecture style. But the other one was when Eric Evans kind of came up with domain-driven design. I mean, this was kind of, again, another inflection point in the way we approach describing and defining a problem. And microservices fits that really, really well. And so from an evolutionary standpoint, I'm not surprised that we ended up with microservices. But it's also revolutionary. It has changed so much in our industry with the way we think about team topologies, the way we think about some of the things we're trying to accomplish in architecture. Namely, business is changing and repositioning at a faster rate than it ever has before. And the bottleneck of all that change is now software architecture. And so the question becomes, how do we change architecture faster? How do we get a better level of agility? And microservices provides that level of agility to be able to evolve and change our architectures quickly as our business changes. And so a lot of tools, techniques, things we've seen in the industry is where microservices, I would see, would be revolutionary.
Okay, so Mark, you said that microservices were both evolutionary and revolutionary, and it helped like a lot of companies speed everything up, like go to the production faster. So do you maybe know what is the next step? What's the next thing that can influence businesses the same as microservices?
So it's interesting. I get this question a lot about so what's next? Is microservices the thing? And I'm going to link, Milan, that question with kind of the prior one you asked, because one of the things that we've learned in the maturity and kind of getting off the hype curve is that microservices is really not a silver bullet, and it's not suited for every single problem. And so to quickly answer your question, it's what we've learned and kind of the next steps is really hybrids are really the king. This thought about, oh, we've got a new system. We're going to use microservices. Well, maybe microservices is suited for one part of that system, but not all of it. And this is where I think we've learned where our struggles are, because some parts of the system need those high levels of agility or scalability or fault tolerance, but other parts of the system don't. And when we try to use microservices for the entire system, that's where we start getting into trouble, because we're trying to shoehorn in an architecture style that really doesn't fit our domain. And that's where hybrids come in. This realization that, sure, we could use microservices, but for the other parts of the system, we could use something like service-based architecture, or even break that system apart so one part of it is even a monolith, which is a lot cheaper and a lot more effective. Because you see, with microservices, one of the things that's necessary is also to break apart our data. And that becomes extremely difficult when we're talking about things in applications that really require a cohesiveness and connection of that data. So hybrids really are where we're headed. And it's interesting how we've arrived at this spot because of just the pain I think that most of us have experienced. So the key takeaway there is just to remember, not every portion of an application has to be microservices. And one of the, I'll say, secret sauce of really either creating a microservices system from scratch, greenfield, or even a migration, is to move to service-based architecture first. This is an architecture style that uses very large, coarse-grained services called domain services. And it's still a distributed architecture. It can still share a same database, but the value we get from moving there first is knowing which of those domain services really need to be split up further. And that's where we end up forming these hybrids, which are really, really effective architectures.
Yeah, I would say a great answer. And you also basically answered my next question, or like the microservices, the silver bullet, because I keep hearing about about people when they're trying to develop architecture, just use microservices. Like, it's not the solution to every problem. Like, you have to use the right tools for the job.
Exactly. Yeah. There's so many architecture styles out there. Yeah, I just mentioned service-based architecture. There's event-driven architecture, space-based architecture. And then we still somewhat have service-oriented architecture, but that's pretty fallen off. That's pretty much fallen off of the choice of architecture styles. It's really still well suited for systems integration, which it does really, really well. But from developing individual systems or applications, that's kind of where microservices really took over from that. But then monoliths are not dead. We still have things like the microkernel architecture, the modular monolith, and even the old layered architecture. These all still have superpowers. And most of those three I just mentioned, those superpowers are really about the simplicity and the cost, which they're fairly cheap. Those are really well suited for fairly simple, straightforward websites or applications that don't need a distributed architecture. So there's a lot of other choices out there, and microservices is just one of those 8 choices. So yeah, except we do get excited about new things.
Of course, especially engineers. You know, they always like to try to build new things, try new things. So yeah. And also you were talking about splitting like the application into smaller parts and smaller parts and smaller parts. So I would say that maybe for now the smallest part is like when you move to serverless or to use some lambdas or Azure functions, etc. And then you can only have like one function running there. So what is your opinion about serverless?
Yeah. So you notice in that list of architecture styles I just mentioned, I didn't mention serverless. It's my feeling that serverless is more of a deployment strategy than it is a separate architecture style.
Mhm.
And now it still follows the microservices style. It's just happened to be deployed as serverless functions. Now, there is one other difference, though, that I want to point out, and that is serverless really is more focused on the specific function. Single purpose functions really deployed as separate units of software. Let me give you a good example. Maybe there's a single function to calculate the shipping cost for this item. I want to purchase an item. Oh, I need to know how much it costs. Maybe it's calculating VAT or VAT or sales tax. These are single purpose functions. This is one function, not necessarily one class file, but one function. Whereas a microservice can combine some of those functions. And let me give you a good example. Most of us go on to retail sites to look at items or books or products to purchase. And it's like, well, I'm going to add that to my wish list. Wish list is a really good example of a microservice. It's a single purpose, but not necessarily a function, but it's still single purpose. It does one thing really well, which is to manage my wish list items. So now I've got a lot of capabilities, not just one single Lambda, but a lot of capabilities built into that single microservice to add or remove items to a wish list, view those items, determine whether they expire or not, get a count of those. So that's one of the other differences between serverless and microservices. But that said, it's interesting, Milan, because you touched on another hype curve that I think a lot of us have learned lessons about. That is serverless. Like microservices, a lot of companies, a lot of teams jumped on that bandwagon as well, just to find out that, in fact, it wasn't really effective for the problem we were trying to solve. And, it's kind of interesting. In all these cases where we talk about hype curves and we talk about lessons learned and jumping on a bandwagon of a particular style or new architecture, it has to do with something called domain to architecture isomorphism. Now, isomorphism comes from two Greek words, isos meaning equal and morph meaning kind of form or shape. And so isomorphism really says this: is the shape of your architecture matching the shape of your problem? And that's, Milan, where we always get into trouble. We embrace these architecture styles before looking at the shape of what we're trying to really solve. And when those aren't aligned, things won't work. A really good example. Let me give you a great example. So we have a need in our system for really high fault tolerance. I mean, when things fail, we can't even let the user know that they failed. Things still have to keep working. We have extremely high scalability and elasticity needs. We need very high maintainability, testability, and deployability. We have to have super fast time to market, and we need to evolve our architectures. Well, I have just described microservices. I mean, that is what it does extremely well. As a matter of fact, better than any other architecture style, all of those combined. So what do? We choose microservices But the shape of our business is that we really don't have individual functions that we can just kind of call. Every request goes and ties all these services together, and you can kind of see what's going to happen. It's going to turn into one big ball of distributed mud where every service is dependent on another service and our data is dependent on other data. And that is what I mean about the shape of the problem. So even though the operational characteristics match really well, our shape of our problem is that all the functionality and data is highly semantically coupled, meaning all that functionality is just used together. And so it doesn't lend itself towards breaking it up into smaller units. So this is what I mean about serverless as well. It's the same kind of problem. Can we take our problem and reduce it down to several hundred or several thousand individual functions?
Yep.
And so, yeah, that's what that isomorphism really means.
Yeah, and I'll have to add one more thing when thinking about greenfield projects, when companies are trying to build something from scratch and they just forget their team. So sometimes you have to think about the capabilities of your team. Maybe they're good for microservices. Maybe they have experience with it, but they don't have experience with monoliths, with something else. So I think that people often forget that.
Oh, what a great comment, Milan. What a great comment, because you're right. Out of 37 years of working in this industry, microservices is actually the hardest thing I've ever done in my career. Yeah. It is hard, and it is a game changer across CI/CD pipelines, team topologies, the way we look at data, the way we look at processing. You are so right, because one thing which every software developer in the world will tell you that's absolutely necessary to do their job is code reuse, sharing code. It's a necessary thing within software development. We have to share code. We have to reuse code. And what I'm talking about are time zone extractors, calculators, utilities, logging, auditing, metrics gathering, all these things. This is stuff that's shared. Well, when we move to microservices or any highly distributed architecture, like event-driven even, where's that shared code go? And we start to realize, oh, yeah, that's right. I can't really share code, can I? Well, we can, but it starts breaking all of our bounding contexts that we have and starts to create a big, ugly mess. So you're absolutely right. There are the team skills and the topologies of those teams also matter so much when we choose an architecture style.
Yeah. So it's really good to have you align on this subject as well. Okay, so I would say that we talked mostly about going from microservices to monolith, and we also mentioned serverless. But let's talk about the actual machines where we do the deployment. So let's say a cloud and on-premise. So what's your opinion on that? So we were talking about maybe going back a bit more with the monoliths, not use microservices on everything. So should we use on-premise and dedicated machines more than cloud? What's your opinion on that?
Oh boy, yes, of course I have. I definitely have opinions about that. And I've also observed this as well at my client sites that I'm at, that there's this excitement and trend to move to cloud. And well, let's talk about the first one. All of a sudden, we're starting to see a retreat away from microservices. Now, Prime didn't necessarily move back to a monolith, but rather larger, more coarse-grained services. Mm-hmm. And that was really a lesson learned that I touched on in some of the other things I spoke about with that whole granularity piece. In other words, this excitement about saying, well, every function has to have its own service. And we don't say, but why? Why? Because now we need to break apart our data, which is hard. We need to manage 200 to 300 individual deployment units. And we start to realize, what's the benefit here of this? Now, one of the general benefits, of course, is fault tolerance, because if one of those functions go down, we've got 200 that are still running. The other benefit of that is that level of agility, the ability to respond quickly to change. Because if one sales tax calculator needs to change, that's one single Lambda or one single microservice that I have to touch, change, test, and deploy. And I can do that while everything else is running. I mean, these are the general attractive features of microservices or serverless. But we sit back and say, well, we don't have a lot of change, and it's very expensive to maintain the operational aspects and the management of all these different parts. And it starts to become fairly overwhelming as well. And so we realize, well, why don't we just bring all those into the same deployment unit, a domain service or a mini monolith, we'll call it, and simplify our data structures, reduce all the latency, get better security, and also better deployability. And so we realize, this pendulum keeps swinging back and forth. I think the magic question, Milan, the magic question that somehow we refuse to ask is, why are we doing this? We get so excited about breaking things apart. And then we sit back and go, why are we doing this? We're not seeing really any benefit, and there's a lot of pain. So yes, I am seeing the pendulum switch back to these hybrids where let's break apart our services into really small units, if only there's a need for it. And there are very big use cases, a lot of use cases for this. But that's where I think that pendulum is swinging. Now, the other one you mentioned was cloud, and the excitement of going to cloud. I'm also in my travels seeing a movement away from cloud back to on-prem. And my opinion is it's two factors that are doing this. Well, maybe three. The first factor is a lot of companies moved to cloud as a cost savings effort, only to realize that they're actually spending much more money than they were on-prem. One of those drivers was the fact that generally on-prem systems for any CIO or CTO is generally a capital expenditure, whereas cloud is an operational expenditure. And most companies have a lot larger operational budget than they do a capital budget. The procurement of equipment and networks and databases is a click of a finger in cloud, whereas it could take weeks or months in on-prem systems. That was another driver too there. But realizing, well, we don't really procure much anymore, and we're spending all this money. Another driver that I'm seeing kind of questioning cloud is also a lot of the cloud vendors are in major acquisition mode and are acquiring companies that happen to be our competitor. And so this was actually one of my first we're moving away from cloud efforts, was in fact that use case. So that's another factor. But a third that I have seen is also just control. I'm invoking a service for everything I do, and I don't have much control over that service. I may want to domain partition an event broker, let's say, but I can't do that in cloud environments because it's a service. Now, behind the scenes, I'm sure, for example, Amazon is probably domain partitioning their brokers for high availability and fault tolerance, but we don't have that level of control. That might be a third minor one, but yeah, I think it's that major question why. I think we're starting to finally start asking that magical question.
Yeah, I would definitely agree with the control part. Like you have the control, but you don't have it 100%.
Right.
So yeah, that's the thing. And the other thing that you mentioned, like engineers often forget that like somebody has to maintain the code, the architecture, and everything, and somebody has to write documentation, which we all don't like. So yeah, I would say that we often forget about like the bad side of splitting up our architecture, doing CI/CD deployments of 200, 300 like services, etc. So yeah, I completely agree on everything you said, basically.
Yeah.
Okay, Mark. So the next subject, I'll have to go a bit more personal. So I would like to talk about the non-technical stuff, basically, with you, and like some of the biggest mistake that you can share with us that is maybe not technical, not regarding architecture. So is there something you can share on that topic?
Oh boy. Oh yes, I've made a lot of mistakes in my career. So, some of those have been technical in nature,
Okay.
and my memory is bringing all those back and stuff. I mean, I think all of us have made some major technical mistakes. I mean, we've brought down systems, we've brought down production. If you oh, by the way, if you haven't had that happen, just wait, it will.
You cannot be a software architect if you didn't bring down the production or deleted some database or something.
That's right. But my biggest mistake, though, in my career, which was a game changer for me, was not technical at all. It was actually my first role as a software architect, and I was very well. Egotistical. I was very arrogant, and I had no tolerance for quote dumb questions. And as a result, I was on one particular project where I ended up essentially alienating almost everybody on that project. And it was some people actually quit that project and company as a result directly of me and my abrasiveness. And that was my biggest mistake in my career, but also my biggest lesson learned. And that was that people skills, those soft skills, are just as important as being the best architect or best technologist that you could possibly be. And it was an awakening for me. I'm very sorry that happened, and at the same time, I'm very glad that it happened because it totally turned my career around. I realized that all of us, not just architects, but all of us, can impact another person at work, how we interact with them, how we, something as simple as doing a code review. I mean, when somebody writes code, when a developer writes code, that is really a manifestation of their creativity. This is their ideas. This is their approach. And what do we do during a code review? Well, what we're really doing is ripping apart that person's creativity and their thought process. Um, and it's those kind of things where, depending on how we approach a particular problem, we can influence and impact people's lives. And so, half, in my opinion, 50% of being, especially a software architect, is having those people skills, those soft skills. And that was the biggest mistake and biggest lesson learned in my career, hands down. I'll never forget that.
Yeah, I completely agree. So we as a Vega IT as a company, we do a lot of workshops and and everything like regarding the soft skills, people skills, etc. But before going to that subject, maybe if you like to share, like how did you overcome that problem that you have with the ego and everything that you mentioned?
Yeah, so that's why I had mentioned uh, part of why I'm glad that happened was because it was so extreme. In other words, it wasn't somebody saying, you need better people skills. Yeah, okay, whatever. I saw the impact it had on people, and that hit me really hard. So it was a matter of a lot of self-reflection. It was a lot of having a good friend of mine who stood by my side. He had great people skills. I would consider him at that time my mentor for how to really deal with people. So I really paid attention to how he interacted with people and learned a lot from him. So fortunately, I had a really, really good mentor. And I saw with my eyes, I saw the impact that that interaction made, whether it be Milan, working with a developer, working with a colleague, whether it be facilitating a meeting, whether it be trying to negotiate something with a stakeholder, trying to convince somebody of a particular solution. All of these scenarios involve soft skills, people skills. You know what I think is so funny, Milan? Um, we've been talking so much in this podcast about like microservices and some of the hard things that happen. Well, we call them soft skills, yet they're the hardest skills to obtain and learn.
Yeah, I completely agree. I like to say, like, when you go to school, like to be engineer, you are used to like doing problem solving, mathematical skills, etc. But nobody teaches you how to like work with people.
Yes, yes.
Yeah.
I had no training whatsoever, no classes, no education, no workshops, nothing in my career
Yeah.
that had to do with people skills. It was
Yeah.
all technology. Yeah.
Yeah.
Well, I remember in the mid 90s, Milan, this is what I love about podcasts because we could just chat.
Yeah, I
Um,
agree.
Back in the mid 90s, I, I I was a developer. I knew about 6, 7 different programming languages. I thought I was on top of the world. And I remember I saw a quote from Gerald Weinberg, and he had quoted saying, no matter what the problem is, it's a people problem. And I so remember exactly where I was sitting. I said, well, now that's the most ridiculous thing I've ever heard. No, we have technical problems, Gerald. Sorry, you're wrong. And boy, it took a couple of years, but I realized, yeah, you know what? He is right. No matter what the problem is, it's a people problem. I mean, if you're saying, no, I've got this code I need to develop, well, fine. So you're going to sit in the corner and write a class file. Does anybody need to review it? Well, yeah. Do you need to discuss a different piece with somebody? Well, yeah. Does somebody need to test it? Does somebody need to release it? These all involve people. And I realized, oh yeah, he was right.
Yeah, that's like a brutal truth. Like,
It
programming is a team sport, basically.
Absolutely, yeah. There's very few lone wolves in both software development and software architecture. Yeah.
Yeah. So because I'm a mentor to a couple of colleagues here, and I always like trying to explain them like the technical stuff is the easiest. Like,
Yes.
especially if the project is already ongoing, so you have to follow some rules,
Mhm.
use some templates. You have colleagues there, but the communication, the rest of the soft skills, like that will be hard to learn, and you have to work on that. Like 70% of your free time you have to work on the soft skills, and that's why like the people and experience team here in Vega, like they are trying to hold as much as they can workshops on these subjects, and there are a lot of subjects covering like soft skills and people skills. So that's I would say, yeah, definitely the hardest parts, even though we are calling them soft skills.
Yeah. So Milan, I love your technique, and here's one that I use typically to get people to, and I say people meaning technologists or architects, whoever, to really embrace this idea of the importance of soft skills. So you're a really good developer, let's say. I mean, the most fantastic developer in our company, but so are about 100,000 other people that are all competing for the same job. And so what differentiates you from those other 100,000 people that are all looking for the exact same position? And the answer, it's not technology. No, because there are so many really good experts out there.
Yeah.
The differentiator is a soft skill piece. How you present yourself, how you can work with others, how you present ideas, embrace ideas, resolve conflict, which occurs. Conflict always occurs. Those are the things during interviews. Those are the things that I look for. Because if you've reached an interview level that we're talking, I don't have to ask you about technology. You know, most of that's been already vetted out. What I'm wanting to know are your people skills, how you interact with the team, how you integrate with the team, how you can solve a problem, if you know really what collaboration really means and how you collaborate. These, Milan, these are the keys. Yes,
Yep.
exactly.
I completely agree. So, but there's another subject like hitting there, like that's the domain knowledge. I also try to like explain to my colleagues like soft skills, people skills, domain knowledge. Domain knowledge will bring you like will make you a better developer. It make you a better problem solver for your client, for the product that you're working on, etc. So, what are your opinion on domain knowledge?
Yes, I 100% agree. I think what we really have are really three forces at play here. The technology forces that we've been talking about, you know, we have to have a certain level of technology expertise, those soft skills. But yeah, the domain knowledge. Now, it's interesting. As a developer, a lot of times you can get away without having that key domain knowledge because your primary job as a developer is to apply technology to a problem. Now, there's others you can talk to get additional domain knowledge. But here's the interesting thing, Milan. As a software architect, that domain knowledge is required because you're usually interacting with and collaborating with business stakeholders and also development teams. And a lot of times it's development teams and developers who ask you about a particular domain-based problem. So I agree. Now, that said, I absolutely agree with your premise that as a developer, knowing the domain, in other words, the problem area and I'm saying the word vernacular, but what I mean is the talking the talk, you know, understanding the business terms absolutely helps make a much better product. And I think much more effective solutions. So I would agree. And you know what's interesting, Milan? This, in my opinion, at least for me, is one of the hardest aspects of software development and also software architecture because I'm passionate about technology. I've come to appreciate and understand the need for people skills, but I'm not that interested in business domains.
Yeah.
I mean, whether it be trading or finance or retail, it's like, it doesn't excite me. And so it's harder to embrace and learn something that you're not overly excited and passionate about.
Yeah, I completely agree, especially if you're like just finished like work for one domain for one business, and then you're switching to another, then you have to again learn new things, which is not often that easy to do. But as you said, like sometimes the software architect, basically you're a bridge between the stakeholders and the developers. Like, okay, you have another roles here, etc., but you have to get to know a bit more about the domain and the problems, because sometimes, as we all know, clients don't, or stakeholders, they don't know how to explain everything what they need. So yeah, I would say that will for sure help, like to get to know a bit more about the actual domain.
Oh yeah.
Okay, so Mark, we don't have like much time left, but I have like two more questions. So you mentioned about the mistakes, like non-technical one. We talked about like soft skill, domain knowledge. So what can you like share with us regarding the bad decision in microservices? We keep like reading about those
Oh yes.
those mistakes. We all read the Amazon's post on the LinkedIn. Like you couldn't avoid it even if you try to.
Yep.
So like, what can you tell us about that?
So I'm going to combine. That's a great question, because there have been a lot of mistakes and lessons learned. Kind of one of the first and primary ones, which we've kind of been touching on this podcast, is that granularity is not a guessing game. And what I mean by granularity is the size of a service, not its physical size, but really what it should do. And this is one of the first biggest challenges that any development team faces. Should we have one payment service, or should we have a payment service for each of the types of payments, or even shipping? Should we have a single shipping service or one for each shipping vendor? I can go on for hours on examples of these kind of things. And that, I think, is one of the biggest lessons learned. And it's really, that lesson is to start out more coarse-grained in your services. Make them bigger and only break them apart if you have a really good reason to do so. Some of those reasons being maybe functionality in terms of cohesiveness of the functions. Maybe it's code volatility. Some areas change more than others. Maybe it's scalability and throughput. Maybe it's fault tolerance. There's errors in some functionality that brings that whole service down. These are good drivers. Maybe it's security access control. These are good drivers to start breaking that service apart. But I think that's one of the first lessons learned, or the bad practices within. As a matter of fact, in 2015, I coined an anti-pattern because of this, called the grains of sand anti-pattern. If you picture a beach somewhere, and all those little grains of sand is how we used to, sometimes unfortunately still do, approach microservices. But also, I think the other lesson learned is something I touched on about that isomorphism. That isomorphism matters. Milan, you just talked about domain. Here's why understanding the domain is so important. Because if we pick an architecture that doesn't match the shape of our domain, and every architecture has a shape, that's why things don't work. We don't pay attention to this shape alignment. And I think that was another major lesson learned. But, another one is about data. When we talk about physical bounded contexts within microservices, a service owning its data, well, that's great on paper. But Milan, rarely does it work in the real world. We have foreign keys, triggers, stored procedures, views, all these artifacts. And never mind those, it may be that our data is semantically coupled. And so I think the other lesson learned was that it's actually okay to share data in microservices. Now, what it does is it forms a broader bounded context where we've got multiple services accessing the same schema or database. When, not if, when I do this, I usually restrict the number of services to no more than 6, because then we start running into problems of scalability, connection problems, change control, all of those things that plague shared data. But the bottom line of that lesson learned is, yes, it is okay to share data. And there's a lot of drivers to share data in microservices. So
Yeah.
those are a few.
Yeah, interesting point of view. To be honest, I never thought about it, but it's really good. Yeah, it's sometimes it's okay to share data between services. I would agree on that. Yeah, why not? Okay, and one more question. So 2023, new changes coming in AI, the LLM models, ChatGPT. So what's your opinion that would we lose our jobs or not? And or would just ChatGPT help us or other LLM models?
So my friend has a good analogy to this. Think of way back in the day, the role of an accountant. So what did an accountant do? Well, an accountant wrote on physical books. I mean, they kept what's called the books, and the books in any company were actual physical ledgers. These were physical ledgers that people used to tally, and then they would have minions that would then retally those numbers and columns. And this was not quite an abacus, but this was the day. So what happened? We suddenly got spreadsheets that had a level of intelligence in them. So here's the question: did a spreadsheet replace accountants? No. It significantly helped them in their work. And that's the way I'm viewing AI. So no, I don't think that it will end up replacing any of our jobs. However, like the spreadsheet, can you think of an accountant right now that would be able to get a job if they didn't know how to use a spreadsheet? No.
Hopefully not.
Right, exactly. So this is, again, it's a tool that's augmenting our job so that we can now do other things that are much more important than tallying up numbers. So that's my feeling about AI. It won't replace our jobs, but it will significantly help our jobs and allow us now to do more creative things that AI won't be able to do. I've been experimenting quite a bit of late, say in the past 3 months, with how can I leverage AI for software architecture. And it's been kind of an interesting journey. I've had good hits and I've had a lot of misses where specifically with ChatGPT, some of the advice is exactly opposite. And so it's still statistically, I've got another friend that calls it a statistical parlor game. Statistically, this is probably what the answer is, but it happens to be wrong.
Yeah.
So I'm excited about it. And I'm finding some really interesting applications and uses for it in my daily job. But I don't think it will replace any of us. I think
Yeah,
that
I agree. I completely agree. And like, do you think that we as a software architects, nowadays, do we have to know more about the data science, about the AI that we had to know like 2 or 3 years ago?
I think it is. How do I answer that? I think I want to answer yes, but not to the level of detail that data scientists and data analysts need to know. I do believe that there is a bridging and more of a connection that is necessary, and this I think has always been the case, between any system and its data, especially when we talk about microservices. And we can no longer, Milan, I have been preaching this for over 20 years, and I'm not seeing a whole lot of movement, that we cannot separate the modeling of data separate from the modeling of functionality and the modeling of our systems. We've so much treated these as two separate camps. And again, this is where we run into problems and trouble. There's no synergy between these two things. And I've always felt the future of software architecture is actually bringing the data closer to the processing and closer to the user. And that's where things, for example, like pods, personal online data storage, are starting to gain some traction because I actually own my own data and I allow others to use it. And so I'm seeing that data being closer to the user. This is something I foresaw 10 years ago in software architecture, and I'm starting to see movement in it now, which is exciting.
Yeah. Okay, Mark. So I would like to say that it was a pleasure talking to you and like hearing about your experience and your opinions about a couple of subjects that you already mentioned. I believe 5, 6, maybe even more. So yeah, I would really like to thank you to taking the time and like share everything with us. And I really hope that we'll have opportunity to maybe speak soon to have record a new episode.
Yes. Yes. Well, thank you, Milan, so much for having me on the podcast, and it's been a fantastic conversation. So thank you again.
Yeah. Okay. Mark, have a nice day, and hopefully speak to you soon.
Okay. All righty. Bye-bye.